Welcome back. On this video, we're going to go over how to solve equations. Now, it's not just linear equations. We're going to look at quadratic equations also. Quadratic equations simply means that you've got an x squared or a y squared or whatever variable squared in the problem. We are also going to look at how to solve rational equations. So we're going to look at those three types of problems. Linear is by far the easiest. That's the one that you're most familiar with. And quadratics can get a little harder, and then rational's the hardest. So let's start with, I'm going to look at number 8. Let me get back to the whiteboard here. All right. Number 8. We are asked to solve, and of course I picked the most entertaining since these are the easier problems. 2p or 4 times 2p minus 3 minus p plus 5 equals negative 7p minus 2. It's got a lot going on, but that's okay. As long as we work through all of our operations, it shouldn't be too bad. Go away. All right. We are going to work our way inside out. So when you have problems like this, you want to start with the smallest parentheses and just kind of work your way out. I have a 3 minus p. There's nothing really to do inside that parentheses, but there is a reason that the parentheses is there. I need to distribute out this negative. So I'm going to have 4 times 2p. Negative times a positive 3 is going to give me a negative 3. Negative times a negative p is going to give me a positive p. Plus 5 equals negative 7p minus 2. We're done with the first set of parentheses, but I still have to contend with what's in this bracket. Let's go ahead and combine like terms inside the bracket. We've got 4 bracket. I've got a 2p and a p. We've got 3p. Negative 3 and a 5. Positive 2. Still got our brackets because I still need to fix that 4 on the outside. All right, so let's get rid of our brackets. I'm going to distribute out my 4. Gives me 12p plus 8 equals negative 7p minus 2. Whew, we've done all of this work to get it down to a form that we can now start moving stuff. When you are solving linear equations, and linear simply means that your highest exponent is a 1. If you were to graph it, you get a line, highest exponent's a 1, you're going to get one answer. Or you might get an infinite number of answers, or you might get no solution. It just depends on what you're given. But that's the three possibilities there with linear equations. When we have a linear equation, you want to get your variables to one side or the other, and your plain numbers to one side or the other. I'm going to move my negative 7p by adding 7p to both sides. So we've got 19p plus 8 equals negative 2. I'm going to subtract 8 from both sides. 19p equals negative 10. And then I'm going to divide both sides by what is attached to p, which is the 19. So we end up with p equals negative 10/19. Straightforward. You've done these a million times if you've ever taken a math class, and I know you have. This is what algebra is based off of, is these equations. Let's do one that's a little harder. Number 10. X squared equals 3 plus 2x. Already this problem is different because we now have a highest exponent of 2. We're going to learn later on that there are multiple ways to solve quadratics. For us right now, though, the only method that we have is factoring. The way that factoring works with this problem is your equation has to be equal to 0. When you start this problem, that's your first step. I need to move my 2x and my 3 over. I always want to try to keep my square term positive. I'm going to subtract 3, and I'm going to subtract 2x to the left side. So I get x squared minus 2x minus 3. Notice that I am putting it in descending order. It's going to make it easier to factor. It puts it in a form that's easier for me to recognize. We do want it in descending order. So here's what happens. To be able to solve a quadratic equation by factoring, 2 conditions have to be met. Number 1, it has to be equal to 0, which is what I've got. Number 2, it has to be a multiplication problem. I do not have a multiplication problem right now. I have a subtraction problem. I need to change this to multiplication, and the only way to do that is by factoring. I'm going to use the AC method to factor. Again, that's a previous video. I'm going to assume that you've watched it. If I factor this thing out, we are going to be left with x minus 3 times x plus 1 equals 0. Before I can solve this, remember, I need to have 2 conditions met. Number 1 is it needs to be equal to 0, which we are. Number 2 is it needs to be a multiplication problem, which I now am after having factored. If those 2 conditions are met, you're going to break this thing apart at the parentheses and set each part equal to 0. It's a lot more entertaining if you see it in person, me talking about breaking these parentheses in 2. All right. X minus 3 equals 0. X plus 1 equals 0. What I've done is I have taken a quadratic equation and I broke it down into 2 linear statements. These 2 linear statements are much easier to solve. To solve the first one, I'm going to add 3 to both sides, so I get x equals 3. And to solve the second one, I'm going to subtract 1 from both sides, so I get x equals negative 1. And done. There's my 2 answers. What we're going to find is the exponent here is going to tell me how many answers I get. So if I've got a 2, I need to get 2 answers. All right. What else can we do? I think we should do another one of those. I'm going to clear this. Let's do 16. 16 looks fun. You can probably hear my dog traipsing around in the back here. She likes to hang out and do math. Okay, we've got z times 2z plus 7 equals 4. The first thing that I notice here is, yeah, it's not even, we've got just a jumbled mess. I don't want these parentheses. So I want to go through and distribute out this z. I've got 2z squared plus 7z equals 4. Now I feel like I'm ready to start this problem. So again, number 1, it needs to be equal to 0. I'm going to subtract 4 from both sides. And we're left with 2z squared plus 7z minus 4 equals 0. Okay. Now I know I need to factor again because my highest exponent is a 2. I created a 2 when I had the z times 2z squared, or 2z plus 7. Guys, one of the things I want to point out here, you can't just set, at the very beginning, I couldn't just set z equal to 4 and 2z plus 7 equals to 4. You're not allowed to break these things apart until it meets those 2 criteria. It's equal to 0 and it's a multiplication problem. All right, if I factor this, let's just go through that process again because this one's a little confusing. Do I want to do it all together here? Yeah, let's just write it out. All right, I'm looking for factors of -8 that are going to add to be 7. My factors of -8 that are going to add to be 7 is going to be 8 times -1. Remember, I'm going to go through and I'm going to rewrite this to be 2z squared plus 8z minus 1z, or z, minus 4, still equal to 0. I'm going to group these things in my head, so you're going to notice me use a different color pen here. I'm putting these two together in my head. If I go through and factor the first parenthesis, I'm going to have 2z times z plus 4. Second parenthesis, I need to take out a negative. The only thing that's going to come out of a z and a 4 is going to be a 1. All this is going to do is change my signs, which is okay. Please notice, I still don't have just a multiplication problem. You have to finish the factoring phase. A lot of students will set it equal to 0 now at this point, but you can't do that. It has to be equal to 0, and it has to be just a multiplication problem. This ultimately is a subtraction problem. So let me finish my factoring here. I'm going to take out the z plus 4. That's going to leave me with 2z minus 1 equals 0. I definitely have it equal to 0. I definitely have a multiplication problem. Let's break it apart and set each part equal to 0. So we've got z equals negative 4. And here, if I add 1 divided by 2, I'm going to have z equals positive 1/2. So there's our answer for that one. All right, our next problem is going to be a little harder. And it's weird because we don't really cover this until a little later on. But I'm going to go ahead and remind you of this process. With this problem, it's already equal to 0. So that's a great first step. I don't have to do that. The next step is to look for factors of 60 that are going to add to be negative 7. As you can imagine, if I think about my factors, I've got 1 times 60, 2 times 30, 3 times 10. We could use 3 times 10, maybe. Let's see. Let's write this out. Factors of 60 that are going to add to be negative 7. We're thinking maybe 3 times 10. The problem with this, though, is you're multiplying to be a positive 60, but you're adding to be a negative 7. For that to work, either both your factors have to be positive or they both have to be negative. Now, because I'm adding to be a negative 7, they both need to be negative. When I make both of them a negative, though, I get negative 13. That's not negative 7. If I make both of them positive, I get positive 13, which is still not negative 7. So what happens here, this problem is not factorable. So I can't do it using the stuff that I was doing from the previous section. I'm going to have to pull up the quadratic formula. Now, again, this is something that I believe we cover a little later on in this class. Let me write it out for us. The quadratic formula says x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That's the quadratic formula. The a, the b, and the c are coming from the fact that this statement's actually ax squared plus bx plus c. Again, with the quadratic formula, just like with factoring, it must be equal to 0, and we are equal to 0. At this point, I just pull out what my a, my b, and my c are. So I'm going to make a note. My a is 2, my b is negative 7, and my c is 30. By the way, if you don't know the quadratic formula and you want to memorize it, there's all kinds of songs on YouTube that'll help you memorize it. I did not know this until I was teaching a class one time. The whole entire class broke out into song of the quadratic formula, and I thought I was in an episode of High School Musical. I'd never seen that before, and I haven't seen it since. But yes, there are songs to help you memorize this if you need it. Okay, negative b. So the opposite of negative 7 is positive 7. Plus or minus the square root of b squared, so negative 7. Notice I put that in parentheses because the negative is going to be squared as well. Minus 4 times 2 times 30 all over 2 times 2. So we get x equals 7 plus or minus the square root of 49 minus 240 over 4. All right, so here's the issue. Here's why this thing was not factorable. That 49 minus 240 is a negative underneath a radical. One of the things that you're going to see in one of the videos later on this week is that a negative underneath a radical is not good. It means that we have an imaginary number. So negative is bad. That means that there are no real solutions. I can't do anything else with this problem right now. Once I learn some more math, yes, I can go farther with it. But for what we're looking at, and I believe the text questions, they only want real solutions. So yep, we are done with this particular problem. All right, so let me clear this one out. Where's my clear button? Come back. Right, so if that wasn't fun enough, look at this one. Oh, you're gonna love this one. We're going to do number 32. Equations are fun, quadratics are fun. Let's make it even harder. Let's throw some fractions in here. I do have instructions on how to solve rational equations, and that's included on your rational expressions list. So if you go back and look there, you should find instructions on how to do this. Your first thing with rational equations or fractional equations, however you want to put it, is you need to make sure you pick out things, or you need to look for things that is going to send the denominator to 0, because when the denominator goes to 0, that's bad. It's easy to see what's going to make the first two denominators go to 0. This y squared minus y, though, is a little bit more complicated. So before I figure out what's going to make the denominator go to 0, I'm going to factor that and see what it's composed of. Y squared minus y, it's a binomial. I can take a GCF out. I can take a GCF out of y, actually. And if I do that, that's going to leave me with y times y minus 1. Okay, so it's basically just an amalgamation of the other two denominators. If I look at y minus 1, if y was to be 1, that first fraction would go to 0 on the bottom. And why? Let's talk about for just a second, why is 0 bad on the bottom? When you try to divide by 0, you get something called undefined. You cannot divide by 0. The way I explain division by 0 is it's where black holes are created and worlds are destroyed. We do not divide by 0. So I need to make a note here that y definitely can't be 1. What that means is that if I work this problem out all the way to the end after I do everything that I need to do and I get an answer of 1, I have to throw it away, because that answer of 1 is going to make the first denominator go to 0, and it's actually going to make the second or the third denominator go to 0, because if I put a 1 in there and I get 1 minus 1, it doesn't matter what the other y is, it all goes to 0. Okay, what would make this y go to 0? Well, if y was 0. So that's the other thing that y can't be. Okay, these are called your restrictions. Anytime that you have a rational equation, you need to find your restrictions first. We write our restrictions down, we're going to set them to the side, and we're going to move on to another part of this problem. Just like when we were adding and subtracting rational expressions, I'm going to figure out what my common denominator is. So my LCD for this problem is going to be y times y minus 1. Remember, you're taking all the different denominators, you're accounting for every part that shows up. So this is all the different pieces. Unlike last time where I would find a common denominator and put the common denominator in the bottom, make sure everything had the same denominator, I'm going to do something a little different. I'm going to multiply every part of this equation, or every term in this equation, by the common denominator. The only time we do this is if we are solving a rational equation. By doing this, we should see some things canceling out. This y minus 1 and this y minus 1 are going to cancel each other out. It's really like you're multiplying by this over 1. I know it's getting kind of cramped here. I'm running out of room. On the second fraction, I'm going to see the y disappear. Now remember, when you cancel stuff out, you're getting 1 in its place. On the last fraction, I'm going to see both of them cancel out, the y and the y minus 1. So I've got a 1 and a 1. What I want you to notice here is along the bottom, you've got 1s on everything. That means to me that I don't have to keep the denominator because anything over 1 is just going to be itself. Let's see what we've got left over. From this first fraction, I've got the y and the 2y. So I've got y times 2y equals. The second fraction, I'm going to have 5 times y minus 1. And then the third fraction, everything canceled out except for the 10 minus 8y. Let's clean this up. So y times 2y is 2y squared equals 5y minus 5 plus 10 minus 8y. Ooh, I can combine some like terms in the second part here. That's going to give me negative 3y plus 5. Okay. Here's where these problems get really frustrating. I have done all this work, and it's like I'm having to start over again. Because what I have done is I have now introduced a square into the problem, which means I need to factor this problem. I'm going to have to set it equal to 0 and then try to factor it once everything's moved to the left side. So I'm going to add 3y, subtract 5. So I'm left with 2y squared plus 3y minus 5 equals 0. All right. So I'm going to run through and I'm going to look for, I'm going to do the AC method or factoring by grouping, whatever you want to call it. I need to find factors of negative 10 that are going to add to be 3. Okay, cool. Definitely 5 times 2. I need to multiply to be a negative 10. And I want to add to be a positive 3, so I'm going to make my 2 negative. So if I rewrite this problem, I'm going to have 2y squared plus 5y. Remember, we're going to take this 3y and give the y to both of our new factors. Equals 0. All I've managed to do is rewrite this problem to be 4 terms instead of 3, and I love having 4 terms instead of 3 because that means in my head I can group the first 2 and the last 2 and factor accordingly. Let's factor out a y. I'm going to factor out a negative 1 because that's all that's going to come out. Oops, sign changes. Oh, these two match, so I'm going to factor out a 2y plus 5. These are with y minus 1 equals 0. We have done all of this work just to get it equal to 0 and get it to be a multiplication problem. Once those two conditions are met, you can break it apart and set each part equal to 0. Okay, and now I'm going to solve each part. First equation, I'm going to subtract 5 divided by 2, so we end up with y equals negative 5 halves. Second equation, I'm going to add 1, so I get y equals positive 1. All right, before I say yes, these are my 2 answers, I am done. Remember, at the beginning of this problem, I set restrictions because some answers could cause it to go to 0. If we look back, we couldn't be 1 or 0. But when I work this problem out, I got a y equals 1. We have to throw that answer away. We can't use that answer because it's going to make the problem go to undefined, and we don't want that. So even though we had a square where we typically get 2 answers, on this particular problem, we're only going to get the y equals -5 halves as the answer. All right, so that's all I've got for equations. Remember, guys, if you have questions, you're more than welcome to get in touch with me, and we will go over whatever questions that you have. I will have office hours; those are posted in my syllabus. So yeah, there you go.